Today I am going to explain this DOM-XSS vulnerability which was reported by the user Samuda in January 2023, and this is basically an improper verification of supplied URL that causes this vulnerability. This was in a page where an instant games would be used, and that was the case. And today we are going through these vulnerable codes snippets, how they causes the problem in the Facebook ecosystem. And after that, if you are not familiar with the cross-site scripting and DOM-XSS, you should to go through all of these labs, which are the best resource I have ever seen on the internet, and you should to go through and try to solve these all of the lab without seeing the solution. It would be a great idea if you want to really deep dive into the DOM-XSS vulnerability. Like DOM-XSS in AngularJS expression, this was a module also of JavaScript which is being used and which is also vulnerable for the DOM-based XSS. So here is also a module which was vulnerable to that DOM-XSS vulnerability. That module, that JavaScript module, was being used in Facebook, which was, I think, React.js. Yes, here you can see that the React is being used. So this was vulnerable, and we are going through this lab to solve this lab reflected XSS with AngularJS, which is pretty much similar but not the same vulnerability as described by the user Samuda in this blog post. So without any further explanation, let's dive into the vulnerability and see how it goes. So basically, if I go through this basic definition of DOM-XSS vulnerability, it will be a huge video. I assume that you also know about the DOM-XSS vulnerability. If you are not familiarized with what is DOM-XSS or what is DOM, I have explained in my previous video as well. Here you can check out the video and discussed what is actually the DOM and what is the DOM-XSS vulnerability as well. So you just have to move there to my channel, and my previous video is regarding this, and here I have taken a little bit time to explain this concept to you guys so that it would become easy to refer where the video is, which video I am going. Actually, I will also leave this link of this video in this video description as well. This is the video which I am talking about, which was the Facebook post message DOM-XSS. Here I have already covered what is DOM-XSS if you are not familiarized with that. So also make sure to subscribe my channel if you are new to this channel. If you don't know about the DOM-XSS, first you should to go through all of these definition of OWASP Foundation and the definition by the portswigger.net, which is a really awesome resource where I always try to seek for the knowledge of bug bounty as well. DOM-XSS in instant games due to improper verification of supplied URL. Basically, there was an input which is being supplied by a user, which was being verified by the module, which was verifying by the framework of React.js. This verification was not correctly verifying the supplied URL. That causes the problem. This bug could allow a malicious actor to take over Facebook and Meta account after tricking the user to play an instant game. What was this bug about? This bug could allow a malicious actor, a hacker can take over Facebook and Meta's other account as well after tricking the user to play an instant game. It's like she can send a URL, crafted URL, and the vulnerability it is going to leverage, which was DOM-based XSS, in order to take over the victim account. This was the basic idea. This bug happens since the Go URI on window module, which is widely used in Meta platforms, fails to verify the schema of the supplied URL. I hope you also know about the schema. If you don't know about the schema, let me explain you this as well to make clear what is the schema. For example, this is the URL of the Yusuf Samuda's website. Now here is the schema, which is https:// this is called schema. So the problem was there in the module of the Go URI on window, which is the name of the module being used by the Facebook. It was not correctly validating the URI schema. URI schema, that for example, if it is not validating that it is actually a HTTPS or HTTP URI or schema, so this causes a huge issue. For example, an attacker can perform like JavaScript :alert, like // alert. This is probably I have seen most in most of the cases hackers are using this payload in order to trigger the XSS vulnerability, which is a DOM-XSS vulnerability. So instead of passing the schema of a URI, a hacker can craft a JavaScript ://alert as a payload, and it will trigger the XSS as well. So this was basically the Yusuf Samuda is trying to explain. Meta platform fails to verify the schema of the supplied URL. The supplied URL basically is controlled by an attacker, by a user which is being supplied and which is being validated by the module, which means we can supply a JavaScript URI. This was the talk which I have explained here. This means that we can supply a JavaScript URI schema and achieve a DOM-XSS. This is a little bit explanation. You can see that this is the summary of the bug. Here is the detail. The function inside the Go URI on window module has this code. This is the code. You can go through as well. Let me explain a little bit, but this is a very tough and complicated code. I am going to give my best, try to explain what it is and why it is being used right here. So __ D Go URI on window, and after that it was the first the name of the module, and it is passing as an argument, and second argument is basically an array, which is a const URI utils and fblogger and error. This is basically the second argument, and in the third argument, which is an anonymous function, is being used, and inside that function there are many arguments like a, b, c, d, e, f, g. This is minified form of the JavaScript. Function a is a function, and inside that a and b argument is being passed. After that a variable is being declared which the name is e, and type of b is being checked if it is string. Okay, type of b argument which is passed at here, if it is string, then if it is not, then what it can do, d const URI utils dot get URI b. If it is a string, then it is doing something with the b using get URI function, and const URI utils is being used. Now in further we are going to explain what the actual code is doing, because in detail Yusuf Samuda has explained in that blog. So before that I am not going to mess around this code and explain. I do not want to make it more complicated so that you didn't get the idea what it is actually conveying us. E argument a dot location equals to e dot toString method is being used. A dot location mean window dot location. If it is a string, then what it is doing, it is setting, if e is an argument, b is a string, then utils is doing something with b variable as well. And after that what it is doing, e argument, if e is being passed inside this condition, a dot location is equals being set by e dot toString method. Using toString method, it is setting the e variable. If it is if e is not a string, it is being converted into a string. For example, e is a number like 2 plus 2 equal to 4. If it is not a string, then it is converting it into a string and setting it in a location window dot location. If you are not familiarized with what is window dot location, you should to inspect any of the current tab of your URL, and what you can do, you just have to type window dot location, and after that you will get the URL of your website inside the console window. This is being set at there. If it is not a string, it is being converted into a string, and after that it is setting the current type URL into that string which is being supplied by the user. Else, if it is not a string, then what it is doing, it is storing inside the a, which is like a global variable, invalid URI plus b dot toString method is being used, provided to go URI on window. Okay, this is a string, and inside that it is being converted into a string, the supplied URL, and after that what it is doing, provided to a go URL. This is being printed as it is because this is a string. After that, C into FB logger, which is being passed, and commit infra, and dot blame to previous frame dot must fix, and a being passed as an argument. And after that, G and default is equal to a. If nothing is happen like this, if this function is not getting executed in any case, so the default will be G is setting, A is setting to be A is passing inside the G as a default, and here it is passing an argument which is a 98. Okay, I don't know what it is, but we are going to see what the actual code is doing. We will go through again this code snippet, where is the vulnerability lie and what is the actual cause. I think this code is making the problem at there. In specifically, this if else statement is doing something wrong inside the function. So we will see how it is doing the things wrong. It checks if the supplied argument, which should be the URL to be passed to the window.location, is a string or not. What it is doing, it is basically checking a supplied argument which should be a URL, which is basically a URL to be passed inside the window.location, which is being passed inside set inside the window.location, if it is a string or not. It is being checked if it is a string or not, while we are going to set this current tab URL inside by a supplied URL by the user or an attacker or whatever. So we should have a check if it is a string or not. If it is not, then if it is not a string, then is would just do to convert into a toString method. Okay, then what it is do, it is basically convert this into a toString function. It uses the toString method to convert this into a string. To just do toString method conversion and set the value to the window.location. First it converts the supplied URI or URL into a string using the toString method conversion, and after that it is going to be set to a window.location, which is being used at there. You can see that e.toString. Now we will go through how we can convert these numbers or supplied URL into a toString method by a string. For example, here I am going to explain a little bit so that you can get the idea what it is actually trying to convey us. For example, here I have basically used a pre-built, I have made my own way to explain this. For example, let A is 3, let B is 4, console.log a plus b, which is going to be 7, and after that what I am doing, I am storing these variables, a plus b, let star str, means string or whatever, this is a variable, and inside that I am storing this a plus b. After that, what we will do, let new string is equal to string.toString. This will convert our a plus b into a string. This will be 7, which is being plus at there, but it is converting into a string. So we are going to see that how it is happening. Now you can see that color of this is changed. If the number which is 7 being declared, which is 7, this and this is a string. So if you do not know how it is a string and how it is a number, so basically what you can do, you just have to type, sorry for that, I am going to explain you. So what you can do for that, so you should to use a type of function, which is like here I am using let type. You can use any variable. Here I am declaring a type variable, and inside the type variable what I am doing, new str, sorry, it is being wrongly interpreted, new str dot type of, we can use type of method in order to pass this new str. And after that, what I am going to do, I am going to console.log and after that we are going to use type. And here I am going to see, you are going to see that this is this variable having type of, new string variable having type of string, which is actually, you can see that here it is not a string, but here it is string. Why it is string? Now we are again going to explain you in a little bit in a more detailed manner. Like here I am going to use the type of method, for example type 1 as here. Okay, so you can see that the type 1, and here I am going to console.log this as well, in order to explain you what the actual toString method, how it is converting these numbers and other variables into a string. So for example, here I am going to see what is the actual a type of the str a plus b, which is a number, and here we have used the toString method at there. What it is doing, the toString method basically converting the str number into a string, and after that we are going to check the type of method and saving it at there and console.logging it there, and same thing is going at this place as well. Now I am going to print this. So what it is doing, basically it is saying that the type of new string, basically why it is giving us both of these new string, because the new string is stored as having stored the string of this str.toString. So what we have to do, we have to use str, not new string. Okay, we are going to check this type, this variable's type. So sorry for that. And here you can see that this is actually a number, this 7 is actually a number, and this 7 is actually a string. Basically we didn't use any string at there, but we have converted this number into a string using the .toString method. So this was the actually being used at there. You can see that .toString method to convert a number or to convert any supplied URL into a string. This was the actual, it is saying that just do toString method conversion and set the value to a window.location. So the process here is vulnerable, since GoURI on window assumes that GoURI on window, which is the name of the module. The process here is vulnerable since GoURI on window assumes that the value supplied is either a string, the supplied value either a string, which then would use const URI utils to create a URI object and verify its schemes to be whitelisted or a URI. What it is saying it there, the process here is vulnerable since GoURI on window assumes that the value supplied is either a string. If it should be a string, it is assuming just that is the problem, which then use const URI utils, which is at there. You can see that, which is then using const URI utils to create a URI. It is why it is being used to create a URI, to create a new URI based on the supplied URL, which is being passed by an attacker or a user, whatever. You can see that say that const URI utils to create a URI object. To create a URI object, I think you are familiarized with the object in JavaScript. You just have a basic knowledge of a JavaScript in order to understand this. This is a prerequisite. If you are not, you can search it straight away like this, and you will get the object in JavaScript, object in JS, and you will get a lot of resources. Here I am going little bit explanation of what is basically let, for example, a is equal, and here you can see that, and I am going to see that b having the value, this is an object, this is an object. This is basically a form of object. You can pass many values as you want, like C colon C is a key and its value is this, B is a key and its value is this, and second key is C, and after that you can pass anything, okay, at there. So this is basically a form of a object which is being used in there as well. So it is creating a URI object and verify its schema to be whitelisted. It is verifying its schema to be whitelisted or a URI object. What it is doing, if it is verifying whitelist, or it is using a URI object which must be secure, and for that it is automatically just convert it to string using toString, which would return null in case the scheme is not whitelisted. What it is saying, object which must be secure. If it is not secure, if it is not correctly verified, then there can be a malicious input can be commit there, and for that it is automatically just convert it into a string. It is not basic, it is automatically converting it into a string, any supplied URL, using toString method, which would return null in case the scheme is not whitelisted. If it is not whitelisted, if it is not defined at there, like whitelisted means that, for example, do not allow, like if it is correctly whitelisted, then you can see that here will be a check if URI, for example, I am assuming that equals JavaScript, then you should to break, something like that. Not exactly, but I am assuming something like that being whitelisted. Okay, if it is explicitly not whitelisting this or any other suspicious URI, then there is a problem, then it will return null variable. Okay, for example, an attacker came and he did not use this JavaScript, but it is used like this, which is also correct, I think so, but its S is bigger than the script, then this whitelist is going to be bypassed, and here will be, it is, what will it return? It will return the null variable. Okay, it is return null variable. In this case, the schema is not whitelisted. However, it doesn't check if the object is an instant of the URI object, and because of that we can just supply, for example, an array which contains a JavaScript URI, and it would pass the check. However, it does not check if the object is an instant of the URI object. It is not actually checking if the object which is being used to create a URI, which is actually an instant of a URI object, and because of that we can just supply, for example, an array. It is saying that instead of passing a JavaScript URI, if we pass an object at there, it is not checking if this object is actually from the instant of the URI object, or it is from the attacker or a user, or it is from the user. Okay, because of that we can just supply, for example, an array. Here it is saying that we can supply an array which contains a JavaScript URI, and it would pass the check. This will bypass the check. This was the actual case. If we pass handcrafted an array which contains a JavaScript URI like this, so this will pass the check, and here was a bypass, so we can give a pop-up or a DOM-XSS vulnerability. I found out that the instant game is vulnerable and other places too. It is saying that I have discovered that instant game is vulnerable and other places in the Facebook ecosystem are also vulnerable in this website. This bug. And this in different places in the platform are with attacker control input being passed to the Go URI on window. The attacker controlled input is being passed on Go URI on window without previously converting the input using const URI utils or URI modules, without previously converting the input URI into a const URI utils or URI modules. In other places I found that there is no check like this. There was no const URI or a URI being used. It was straightforwardly passing the attacker controlled input. So this was a huge problem. And here two modules seem vulnerable in instant games. Both are accessible by the attacker since they are their handler for the cross window message received by the iframe window hosting the game. Basically, it is if you are hosting another website, for example, which is a cross domain website, so you should to use post messages in order to communicate with that, which bypasses the CSP and many other things. So there was a no URI check. Both are accessible by the attacker since they handle they are handler for the cross window messages. Cross window messages like which is with the website, two websites talking to each other, but they didn't having any same origin. Okay, message received by the iframe window hosting the game. The idea behind this, let me explain a little bit in deep. The idea behind this is Facebook is using actually iframe to host the attacker or a user website, which is a game website, and you can basically invite the users of the Facebook who's having the Facebook account as well. And after that, what you can do, you can establish a cross window message by using a post message or an iframe with parent window and the child window. If you are not familiarized with the term parent window and child window, you should to go through of this video. Here I explained a little bit in depth as well. So now I am not going to explain this in depth because the video is going to be very long. After that, use interactive plugins SDK message handler .react and exactly the open URL sync messages. This is the only available to few games and few types of games like Canvas on Blue and Canvas on Commit. I did not invest much time trying to hit this one. So it is saying that it is basically using inside the React and open URL sync messages as well. And this is the only available few games and few types of the games like Canvas on Blue and Canvas on Commit. I did not invest much time. I didn't spend much time in order to audit and hit this. If it is vulnerable or not, you can check it as well. Instant games open external link dialog React, which is a method which is called when show generic dialog sync messages received with the request set to the open external link. What it is saying basically, this is the name of the you said that the function or a method which is called when the show generic dialog sync message is received with the request set to. If the request set to open external link, this one is vulnerable too, but requires a click. This one is also vulnerable. This method open external link, which is a button or something like that. If you click on this, which is also vulnerable, which requires a click as well, because below the poke to exploit this one because while hosting a game in an instant. What it did, it basically hosted his or her game inside the Facebook, and this was the actual payload and the poke, which is index.html. Here you can see that here it is used a script. Inside the script a variable const which is named as display window.display other app id, your other app id is here. Other app id means your app id, like which is being given to you when you open the Facebook developer account. And after that, custom data would be set into 42, and window.onload function is being used at there. Inside window.onload, a function is being called Facebook instant.initialize async then Facebook instant.start games async. What it is doing, on loading it is starting the game actually. And after that, where a variable is being declared whose value is being set to 0, function fun is being declared, and inside that an argument which is being passed, which is e. If I equals 5, if I is 5, window.top.post message. What window.top.post message? A post message is being used here, and inside that post message, type of the show generic dialog sync and content type data. And inside the content type, here it is using the actual payload, which we did not expect in our dreams, that how sharp the attack is, because we didn't even use inside the content. So here what it is doing inside the content key, it is setting an object whose value is data, whose key is data, and value is being set to an object which is having the JavaScript and opener eval. So actually JavaScript opener eval function is being used, which inside the pop, and new async function it is used. And literally I am explaining to you that, guys, it is really much complicated, but I am giving my best trying to explain each and every step. So a new async request is a built-in method of JavaScript which is being used at there. And after that, it has user the 4 backslashes, and after that /API/GraphQL, which I know that which is a JavaScript, and it is a GraphQL endpoint which makes a bunch of calls to the GraphQL API of the Facebook. If you are not familiarized with, you should just type here GraphQL, and you will know you will get the original documentation from the Facebook. Here you can see that I have already go through on that as well. So basically it is making a call to the GraphQL, and what it is doing, it is setting a doc ID which is this ID, and after that it is also using variables and slash and forward slashes and an empty object as a value of the variables. And after that it is sending that message, and the second key of the object which is request, and its value is open external link. And after that SDK version 7.0. These are formalities which you should to obey if you are making a request there in order to make a successful request. That's why it is being used at there. And this was the actual JavaScript opener and eval function, which is using the doc ID, and further inside we can see how it is converting an on message which is being used, and inside that on message what it is used, and e is passed in an argument, and after that f is equal, inside f what it is setting e.data, the data which is being set into e.data, and if type of f not is equal to string, what it is do fun e.source, and this is going to be used. And after that fbconfig.json, which is at there instant games, and after that platform version and rich gameplay, custom update templates, and play turn, example play, and navigation menu versions, and nav floating. After that JavaScript Here it is explaining a little bit, which we can see that javascript opener.eval new async request, and this which we have discussed it there at the post message, inside the post message, like this piece of the code which now he is talking about, would use a Facebook module to make an async request. If you are not familiarized with the async request, you just have to Google it and you will find out many resources out there. You use a Facebook module to make an async request to the GraphQL endpoint. What it is using, what it is saying, it basically request an async request to the GraphQL endpoint. So later Meta confirmed that this was causing DOM-XSS in other places in the Facebook platform, and those ones didn't require user interaction. It has identified at some places, but there are many places which is this module is being used wrongly. So Meta confirmed that there were other types of bugs. Meta has also a big team of engineers, security engineers, which always audit their codes, and they later further figure out many ways in which they can execute DOM-XSS without any user interaction. A report was sent by the user Samudha on October 2020, and report sent acknowledged by Facebook. Meta fixed December 12 and December 13 62,500 bounties, with bounties awarded, although only 28,125 was paid here. Meta rules about ATOs, and you can say that clearly says that the XSS that directly leads to ATO should be rewarded 5,000, not included in additional bonuses. I raised this concern to them, and this should be corrected. So this was the actual explanation. I hope you enjoy this. So now we are going to explore the DOM-XSS lab, which basically use document.write, which is a dangerous method to write inside a sync using a source which is a URL. Like inside the source, where location.search is being used, a search functionality is being used. Inside that, a URL which is given by the attacker or a victim or any user. So this URL is being reflected inside, being right inside the sync. This is the problem. This lab is not exactly the same of the web vulnerabilities that we have discussed, but it is similar type of a lab. That's why I am going to solve this. Here is a little description of the lab. This lab contains a DOM-based cross-site scripting vulnerability in the search query tracking functionality. There is a functionality which tracks the search query, and it uses JavaScript document.write, which is a JavaScript method function which write data out to the page. Okay, it dynamically taking data from a source, which is a URL, and writing it down to a website sync. Function is called with the data from location.search, and location.search is being used. As we have seen in the previous write-up, location.search is being window.location is being exploited. Same here, location.search is being exploited as well, which can control using the website URL. Solve this lab, perform a cross-site scripting attack that calls alert function. In order to solve this lab, we have to give a pop-up alert, and we will be able to solve this lab. So now we are going to explore what it is and how we are going to solve this. Before this, you just have to make sure to sign up. If you are not familiar with the Sportswagger labs, these are awesome resources to learn and practice the vulnerability types. So you just have to click on the create, and there will be a simple straightforward methodology in order to create a new account. So here I am going to log in, and here you can see this is our lab, which is DOM-XSS in document.write sync. Now here inside this feature, you can see that there is basically a search box has been given in this lab. What we are going to do, we are going to just type test, and hit the search button, see how it is working. Now you can see that the search query is being reflected inside this page. And now we are going to take a look. In order to exploit any DOM-XSS, you just have to inspect that. You do not go at the view page source part of the website, because there is nothing to do it there. So here you can see that inside an h1 tag where a test is being used, and after that we are going to see that here is basically inside the head. Now we are trying to see any DOM or any JavaScript which is being used at there, so we can explore further how it is working actually. And probably there will be a JavaScript. Here you can see that under the section class search feature there is a JavaScript. Now we are going to expand it so that we can take a better look at that. And here you can see that the function track search query, which what it is doing, it is writing the test using the document.write, and inside this function here is an image source, and what it is doing, it is referring somewhere resources and images, tracker.give and search term plus query. The query which is coming from our source, which is a URL like test. We have seen that we have used the test as a query parameter, and it is being reflected inside this. It is taken from the source, which is the URL. So what it is doing, it is basically dynamically writing the search query of an attacker, of a user, using the document.write inside the source. What is the source? Source is the DOM of the DOM of the website, as you can clearly see. So after that, what we are going to see, that here is a variable declare whose name is query, and inside that a function, anonymous function, where new URL search params and window.location.search is being used. As you can see that we have read here that location.search is being called at there. So that causing a problem. Location.search, what it is do, it is basically fetch the URL of the website. If you aren't familiar with this, so here I am going to give a basic demo of what actually the location.search is. So here you can simply type location, and here you can see that location.search. Here it is not, search functionality is not available, so you can just type location and you will get the URL of the current type, which is Portswagger. Here you can see that. But here is the term search feature is already used, so you can just access this using the location.search method. Hello, here you can type location.search and you will get it, the search, the search query which is being written inside the sink using the source. Okay, if you are not familiarized with what is source and what is sink, so I suggest you to watch my previous video where I have in detail I have discussed about this. If you are not, you are getting not, your concept is not being cleared at that video, so you just have to refer to Google and the ChatGPT as well, where you can find a lot of resources, and this will be very helpful if you go through this as well. So here basically now I am coming back to my this little script actually, and now I am going to copy this and paste it there in order to take a better look, so that you can analyze better at there. So here you can see that a function is being declared whose name is track search query, and document.write is the method which is using an image source. Inside the source, here you can see a search term and a query is being used, and query is getting being written inside the sink of a website, and after that a query is being declared. A query variable is being declared. Inside that query variable, this new function is being stored, whose name is new URL search params. And after that, window.location.search is being used, and .get method is being used in order to grab the search query, which is test, or which can be a malicious JavaScript payload. We will try this as well in order to give a pop-up as well. So if query, here is a term, like here is a check. If query, if query is given, then what you have to do, you have to use track search query. Basically it is doing some sort of checking the IDs or setting the IDs of something. And so in order to do that, what we are going to use, this param, simply this image search tag, in order to see if it is solving the lab or not. But it is not getting reflected. But here you can see that it is writing down our payload inside this source. This is basically the source of the website. You can see that right there. Now I am going to inspect this, why it is not getting executed. Maybe we have did something wrong, and that's why it is not being executed as well. So here also a image search tag, you can see that. Here is the big question. So in order to solve this, again we are try. Here you can see that it is storing our image tag at there, but it is referring that not found, and we have successfully injected the image inside the source of the website, but it is not getting executed. This is the problem. So basically now we are going to use an advanced payload, which is a SVG payload. So here I am going to execute this, may it works, and here you can see that this is our majestic pop-up, and we have solved the lab successfully. Hope you enjoyed this video. Make sure to subscribe, like and share this video.